can you remove the location of the HMI off of the operating floor to a place where it can be centralized and where people are known to be safe and can take precautions as necessary? Those are the kinds that we are thinking about as we continually evolve our processes and our products that we offer to the marketplace. Interesting time for everybody, including us as a provider to the market. So illness and injury prevention, we kind of think about it on two sides of the coin here. You know, injury prevention, thinking about the layout in a facility is a key part of thinking about automation. You separate the operators from the heavy material handling areas. No more working in densely packed, unsafe coil fields. You can probably think about that in your mind, what a coil field looks like in a typical facility. And there are a lot of potential hazards in that scenario. So we try to address that in the idea of using automation. So we manage the storage areas. We lock them off and prevent operator access when the crane is inbound. If a crane is moving, then that area is no longer accessible to, or somebody enters a facility, the crane is immediately stopped. Things like obstruction management are things to think about as well, to avoid operator areas and work around locations where there are things that will definitely impact the capabilities of the crane, or even just an actual obstruction that gets in the way of it and moving around it. Thinking about illness is a little bit of a new thing, not so much new, but it related to COVID, minimizing the number of operators in a facility and allowing for social distance so that the spread of this, and not only COVID-19, but what may come in the future. So something to think about as we move forward is creating a new safety level in our facilities. Monitoring from a remote location, web-based applications provide the ability to run a facility from a distance. And then also reducing the touch points. I touched on this, mentioned it earlier, you know, electronic data interchange and web services to minimize the amount of paperwork and hand-to-hand contact and touching that goes on in the normal day-to-day transactions that happen in a facility. So how do you proceed if you're thinking about automation in your facility? Really, what's next? And then from a safety perspective, how does safety impact the automation project itself, and what role can you play? How to consider health and safety of the project and the implications on illness and injury. You have the as-is environment, which we would assume in a lot of cases is kind of a manual environment. You have an operator in the facility who's walking around with a belly box and maneuvering heavy materials with a crane and maneuvering through lots of obstacles. There's maintenance and mechanical activities that are going on. And then you have manual updates to inventory management. And you walk across the steps across the screen here, and you end up in a future environment where a facility is automated. You have operators interacting with HMIs and software systems. Maintenance is done with electrical controls, and also it's done on a more of a predictive type of maintenance as opposed to emergency maintenance. And then the inventory updates are automatic. The material that's in the facility, there's always a record of where it's located and how long it's been sitting there, how often it's been touched by the automation, and the status of it at that moment. So you can link it to the records in your internal operating system. So there's a few considerations to think about as you're thinking about automation, and we'll go through a couple of them. The first one I want to talk about is the solution design side of things. So there are a couple of scenarios that happen in facilities that we want to make sure we avoid. The safe stacking practices for materials, and I'll reference coils specifically, but lots of different products can fall into this category in terms of stacking. No bridging of coils and rules for light gauge coils, etc., on how you stack them, how high, how frequently they can be touching each other, and all the things that go into that consideration can be designed into the system and the layout of a facility as you're putting it together in your mind, whether you have an expansion in mind or whether you just want to retrofit a specific facility that you're already utilizing. Those are things that can be done by the automation provider to prevent any unsafe scenarios from cropping up in the design piece of it. You want to separate the operators and automation from each other in the process in the way that you're designing the facility. You want to have them safety interlocked and consider minimizing the personnel in the different zones. Manual areas should be addressed, and no live loads should travel over any operators. And also we talked about obstruction management, but that's a key part of the planning process. And then determining your risk assessment, identifying hazards and interaction with automation to minimize touch points between personnel. These are all pieces of information and activities that you want to design into your facility as you're moving toward automation. We have some examples here of some places where we would try to prevent this from happening in an automated facility. So on the left-hand side, the first picture, you see a set of stairs and a platform so that somebody can look out over a coil field to see what's going on and possibly even identify coils or potentially even operate the crane from that spot. In our minds, that's a safety hazard and someplace that we should eliminate in the future in an automated environment. Those coils can move. Hopefully they look to be secure in this particular environment, but that's a hazard waiting to happen. The second challenge is the bridging of coils. You see a significant gap between that coil in the middle on the top and the two in the bottom, especially the one on the right, which can cause a lot of problems in terms of unsteady load and the potential for one of those coils to become dislodged and roll. And if you've ever seen that happen, it's not a fun sight to see, and a lot of destruction and potential safety problems from that. And then on the right-hand side, you see coils kind of coming unraveled within the field and somebody needing to go in there and address that. And again, that's a problem of just contact and location close enough to those very, very heavy and significant weights of the coils that are in there. Here you see a little bit of a more organized coil field. And we like to mention this in particular. It's a lot about our experience when we talk about how to engineer or create an automated facility. But really at the end of the day, if the people that are operating it don't feel safe and don't feel that they have the capability to do it, then it's not going to work. And so we constantly are working with the folks that we're implementing with, and you should expect this from any automation provider, an interaction that is at a very high level and also down to the floor level to make sure that all the policies and procedures that are put in place address safety. And, you know, in talking to an operator working in an automated facility that we installed, Telia is actually the product that we refer to that drives automation in facilities that we run. And the quote is, the best thing that we don't have to go in there anymore. And when he said that quote, he was actually pointing into the coil field and talked about how he knew every day he was going to be able to go home and be safe and wouldn't have to walk through that potential area, especially for coils that, you know, that range up to 50,000 pounds. They're multiple levels high and could really do some damage to a human body if they moved. So following on that, I'm going to walk through a little bit of an example of a safety layout. Here you see a storage area with different sizes of coils. You see a truck coming down from north to south, and you see a staging area immediately to the right of the truck. And you see different pillars and other things that may be in the way as we move, or transfer cars coming from another bay in kind of the right-hand side of the picture. So I'm going to walk through a little bit of the layout. So in an automated environment, you'd have a fence perimeter to keep employees out of harm's way. It segregates automation from the operators by fences and something like a fortress lock or just a penetration lock that would alarm a system to let us know that somebody had entered it. You have interlocks between zones. Operators cannot access an area if the crane is in it. So you see an example there where the crane came across, and that particular location is inaccessible at the moment because of location of the crane. The crane movement is controlled by zones. So you see we have a zone 1 and a zone 2 in this particular environment. The crane is not permitted to move beyond the automation zone in that automation mode. The software controls the speed near the end of the zone and slows it as it's coming down and getting closer to a place that could potentially, or to the end of it actually. And then if somebody is actually in this area or operating within this receiving staging cradle, you can see that the crane would be prevented from coming across it. And that's simply accomplished by when this door is open, that tells the system that somebody is in zone 1. And so the crane knows that it can't move itself into zone 1, it has to stay in zone 2. If the next job in the system was for the crane to do something with zone 1, it would move on to the next job after that, which could be a housekeeping mode, or it could be the next job to move into the processing line at the other end of the facility. There are a number of things that can be done, but it will move on and then come back to that job that it missed once this area has been relieved of anybody being in it. So along the lines of kind of safety by design, you want to think a little bit through in your process. And when I talk about this as a design phase activity, this is something that you can expect your automation provider to do with you, is identification of hazards, identify the standards that would apply at your facility. The automation provider likely has their own standards and they want to marry them with the standards you have. Talk to the key stakeholders and repeat this process throughout the design, but go through an organized set of steps to make sure that you're identifying the risks that are in your facility that you want to have addressed by the automation, either through safety practices, through the automation itself, or standard operating procedures. Those are the three kind of buckets that this falls into in terms of identifying and mitigating risks in your facility as you're going through the design phase. And again, this applies not only to new facilities or new build outs, but also the retrofitting of an existing facility. So planning is important. It's kind of the highlight there. The next step would be talking about the hardware considerations, and the hardware considerations have quite a range, and they play a key role in maintaining the safety of your facility. What is the hardware, thinking about material handling resources, what is the hardware for tracking cranes on XYZ locations? What determines if the crane is holding a load or not? What's responsible for measuring the coil? Is your provider safety rated? And what level of redundancy is offered in the facility, and what are the fail safes? So let's spend a moment talking about this. These are really important considerations to understand the visual inspection of a product and the handoff between the manual mode to the automated mode, as well as the connection between the software that's driving the automation mode to the company's systems that tell it, for example, coil number 20 is this particular size. I want you to pick it up and move it to this location. If the crane comes down and picks it up and the sensors on the crane determine that that is not what is it expecting, whether it's the size, the weight, or some other factor of it, it's going to park that coil in a place where it can be inspected to make sure that we can address what's the conflict between the two sources of information. There's multiple levels of redundancy that would be built into an automation system and should be built into it, and you should make sure that's part of the process. The crane itself will tell you where it is. You should have validation of that location from other sources of information, other pieces of hardware, which will give you validation of that information, so that there's never any piece where there's a lack of information and confirmation of that information, so that you can feel safe in the environment. Does the fencing layout provide zero interaction with the personnel? So I showed you that design layout image a moment ago. Is there any gaps in the crane itself and the edge of the fencing to prevent or to make sure that there's no problems there? Are there fail safes whenever a section of the fencing is penetrated to make sure that the zones that the crane is allowed to access aren't accessible at that particular moment? And then other things that are, more global in perspective. What if the power goes out? What backup power is available? What happens in that scenario? Cranes can use things like grabs. They can also use things like magnets, which are all powered by the electric grid. And if you lose that power, what happens? Typically, we will build in a redundancy scenario to that where we have backup power for a certain amount of time. If there's a load on the crane at that particular moment, it will be brought down safely into a location that is known and tracked until the power is restored. And it's not a quick drop, it's a slow drop. And there's situations that are addressed ahead of time to make sure that that process is orderly and there's no problems going through it. So other key components that we talk about, we mentioned some of these as we've gone through the presentation. Gates are important. You know, you can lock out an area with a fencing, but typically there may be a need wise where someone would have to get in there, whether it's from a maintenance perspective or audit perspective, or there's some other reason why there would be a need to walk through the field. The gates are key components to be connected to the system so that we know, the automated system knows when somebody accesses an area. The key lock system, again, kind of just for knowledge of the system and making sure that only the appropriate people who have been trained can get into an area. The PLC should be safety rated and have UPS backup power so that their operation is continued and guaranteed in any kind of scenario that comes up. The verification system, there's a safe path for the crane to travel. There's prior to job execution, we validated that this is all possible at this particular moment. So efficiency of operation is a key as well. Feedback on the drives fed to our PLC to monitor speed and location of the crane. So again, there's multiple touch points and multiple pieces of information that tell us that the system is operating the way that it's supposed to and efficiently. And then communications, if you need to emergency stop, if there's some scenario where an operator needs to stop the system, that's possible and we can do it in a safe manner. And that's really another set of things that you need to validate with your automation provider, whomever that may be. Another key component of this is kind of the safety and training aspect of it. When you decide to move into an automated environment, there are considerations that come on both sides of the picture. And it's really, this is the piece that is more on the side of you as somebody who's interested in automation and implementing it in your facility. So rather than the automation provider doing this, and they'll work with you on it, but you need to understand what are the operating procedures that will need to be changed in the new environment. How do we change the operating procedures? What's the process? Who's responsible for doing that? And then how do we train our workforce to make sure that they are able to operate in this new environment, both from the perspective of their standard operating procedures, but also their interaction with the automation system. How is this all documented? How is it conducted? And how do we validate that that is a continuing practice within our facility? Those are all things that are important to understand as you move into an automated environment, that there's obligations on both sides of the fence, so to speak. So I'm going to move in after talking about the design and the hardware to a thought process on how you would move into automation. We've touched on it a little bit earlier, but I'm going to talk a little more specifically about it now. So you've all likely heard the automated environment versus the manual environment. And this is the one place where you'll see a little bit of a mention from a commercial perspective to our particular product. But you see on the graphic here, a left to right movement of what a coil field might look like in a manual environment, and then moving to the middle, an automated grid, and then what we would refer to as our Telia storage environment. So from a traditional manual storage, you have to leave space for operators. It contains significant safety issues, and a coil can be placed anywhere. It's the decision of the person operating the crane where they actually want to put it. And that all becomes dependent upon what they feel like at that particular day and how everything is moving in the facility. If they have a rush that they have to move through, a coil could get dropped or placed somewhere where it shouldn't be, but creating a potential safety hazard in the future. Standard automation or grid kind of system is typically single high. It's got a standard footprint and there's no stacking or safety issues. So it's moving up the curve in terms of safety. But you will see a decline in the amount of coils that can be placed in that environment, therefore reducing your capacity in the storage area. So then you move into what I've referred to as maximum storage, about a 45% increase over the manual option, 300% increase over the standard grid automation option. It's safe up to 3 high and for coils and no stacking issues. And there's a lot of reasons that that can be accomplished. A lot of ways that can be accomplished through the algorithms that are in place in the automated system. But essentially, it's determining where everything can go, taking all the factors weight, size, other things that are there, how quickly you need to have access to this particular piece of material, taking that into consideration when it's determining where to place it. You hear terms like AI and machine learning, that's all built into the system that we've evolved into. We're on our third version of the software right now in terms of what we're implementing at facilities. So I'll call it gradual steps into automation as you think about kind of how you move yourself into this. And I tend to refer to this as manual mode. I called it guided automation or phase one here, but the idea is that the automation software is implemented in a facility. You haven't turned over the operation of the cranes to the software to drive it or to the Telia system to drive it. You still have your labor in the facility, and they're being directed by the automation system to place coils and remove them from their locations. So they're being told where to go based on the input from the company system, whether it's a scheduling system or the ERP or moving it to the closest processing line for the next job. They're being instructed and told where to place things. It determines the optimal safe location and the order of jobs. All the material is tracked. You see improvements in transportation turnaround, so shipping in both inbound and outbound. You improve your line performance, so a day's work is set up in advance so that it can be quickly processed through by whatever processing line you have in place. The implementation, which is a key consideration in all of this, is quick because there's not a lot of retrofitting or other things that need to be done. We can do this in under 6 weeks and likely even quicker than that. And you see an immediate ROI in the implementation of this guided automation or manual mode that we call it sometimes. But you'll see a quick return on your investment, which is minimal when compared to kind of the big full automation thought process. So next would be moving into full automation from guided automation. So crane movement is autonomous and at maximum efficiency. When you think about cranes, we are looking for Class D cranes with level 4 drives. So the crane itself is able to move at a high speed and with maximum efficiency and be driven by the automated software to do that. You get some gains that you may not have thought about when you think about automation that I'll touch on a little bit later, but with full automation comes maximum storage density. And these are all things that can be defined between the automation provider and the company. What are you comfortable with? What are your customers comfortable with? And you may be surprised to understand that as you work through the process. A lot of people, when they think about automation, they feel as though stacking is not something that they can do with their customers. We've seen the opposite happening, where we've shown that stacking can work and there is no issue related to damage or any other kind of problems related to it. So you may be able to convince your customer that stacking is okay for their product. The automation interfaces with the company systems to pre-stage material for processing and shipping. So there's an advanced process that's going on in the communication electronically to make sure that everything is where it's supposed to be and ready. Safety through separation of storage from processing and transportation. So you isolate those environments and make sure that they're fenced off. There's safety in the sense of people not being able to access it without the knowledge of the automated system. You're maximizing the efficiency of the resources. When you think about a crane that is designed at the level that I've mentioned, it is designed to work 24/7 and continue to move. And so if you're going to spend the money to buy something like that, the CapEx expenditure, you should expect to utilize it at full capability. And so things like housekeeping that happen in a facility overnight when typically there's not a lot going on, it's getting ready for the next day's work and continuing to work. Something that we find as an outcropping of automation is the minimizing the wear and tear on equipment and cycle-based maintenance or predictive maintenance as opposed to emergency maintenance. The use of the automated system to pick up and maneuver product and material comes with it a very regular use of the crane, the speeds on the crane, and the movement from side to side. So there's not a lot of movement that could cause damage to any of the components of that crane. So the cycle-based maintenance is something that's an outcropping of that, as opposed to something broke and we need to take the whole thing down and stop the facility. Minimizing damage to the product itself and the financial loss associated with that. We've seen a dramatic reduction in facilities that we've implemented automation from that perspective. And so it's a win for all involved from that side of things. So there's a number of different places where ROI can come from if you move into the full automation mode that you wouldn't get from the manual mode. But again, the thought process is kind of a gradual stepping into it. There are considerations in terms of ordering equipment that take time, and the gradual step could also help the organization get used to it as the process is unfolding. So that kind of ends the formal part of the presentation right now. As Monique mentioned in the beginning, one of my colleagues is here with us on the phone and on the screen. Her name is Kim Hindle. She's our Chief Product Officer. And so I'd like to open up the floor to questions and spend some time doing Q&A for those of you that are interested in talking about automation further, and any questions you may have in particular about the presentation that we just gave.
Thanks so much. Which would you say is the top concern as a facility considers automation? Is there a top concern?
Absolutely. Kim, would you like to take that question?
Sure. So well, most people on this call will be moving very heavy material. So when considering automation, you want to look for someone who has experience moving very heavy materials. Again, Kurt touched on it earlier, but if you're looking at stacking those materials, you would want to look again for experience in stacking and successfully, securely moving around these products. We can't overstress, and everybody should be aware of this, the importance of safety in this type of an environment. Obviously, these are not $5 Amazon boxes moving around an automated warehouse. So you should be looking for a lot of redundancy and fail-safes, as Kurt mentioned earlier in the presentation. For example, you wouldn't want to be reliant on electronic data. You would want to ensure that there's lots of automated measurements to confirm that what you're receiving is what you're expecting, and confirm all of the parameters before you take the lift, for example. So, yeah.
Thanks. And then a little bit follow-up to that, what's the top safety concern that you encounter through your experiences?
So through our experiences, usually where there is going to be an issue is anywhere where there could potentially be manual intervention. So for example, if an operator is scanning a coil to a receiving cradle to receive it into automation, what if the coil has the wrong tag on it or the wrong information? Did he scan the right cradle? Do we have the right information about what is where? So we mentioned earlier, sort of safe operating practices. Anywhere that the operator can interact with the system, it's so important to get that part of it right. Because if you have incorrect information about what's in the environment or what's coming into the environment, those are the areas where things can go wrong. So it's so important to the success of any automation endeavor to understand all of the touch points where there could be some form of manual intervention, and making sure you have the right operating procedures in place.
Thank you, Kim. Any other questions out there? It looks like nothing at the moment. We are going to, as I said, put this up on our website, and contact information will be there for you if you do want to reach out with a question that you think of later. Kurt and Kim, thanks again so much for being here. And to all of you out there, thank you for being here. Please watch for other webinars. We'll be doing these safety webinars at least every month, once a month. And as you know, we've had lots of other webinars that relate to COVID and other important issues that our industry is facing. So thanks again for being here. Have a great one.
Thanks, Monique.
Thank you, Monique.
Bye-bye.